All right, let's dive right into this explainer. We're going to completely flip the script on the usual history of military technology. Normally we only obsess over the big success stories, right? The composite bow, the armored vehicle, the thermonuclear missile. But today, we're looking at the other side of the coin. We're looking at the bizarre, so-called failures that were actually brilliantly conceived, but just hopelessly ahead of their time. So what do 3rd century flaming pigs and 1960s cyborg cats actually have in common? I mean, it sounds absolutely ridiculous, right? But the answer reveals a fascinating, universal truth about the absolute limits of human engineering and the chaotic reality of biological unpredictability on the battlefield. Here is our roadmap for today. We're going to cover 1. The friction of innovation, 2. Beasts of the battlefield, 3. Mechanical and material misfires, 4. The absurdity of total war, 5. Cold War doomsday devices, and finally, 6. The blueprints of tomorrow. Let's get into it.
Section 1. The friction of innovation. Ambition versus reality.
So, what actually happens when a brilliant tactical idea just smashes head-on into the cold, hard limits of contemporary materials? We get what we call anomalous warfare. These are unconventional weapon systems that usually popped up during asymmetrical conflicts. And the crucial thing here is that they weren't inherently stupid or just mad science. They simply failed because the materials, manufacturing, or control systems of the era literally couldn't support the engineering. Their imaginations basically outpaced reality.
Section 2. Beasts of the battlefield. Ancient biological countermeasures.
Let's jump way back to antiquity. Ancient commanders were constantly trying to weaponize animal behavior to solve huge tactical crises. And this perfectly illustrates our first major hurdle: biological unpredictability. Picture this. You're facing a massive charge of war elephants. Terrifying, right? Your infantry doesn't have the mechanical weapons to stop them. But they quickly figured out that the high-frequency squeal of a pig was a perfect, albeit chaotic, acoustic countermeasure. During the Pyrrhic War in 275 BCE, and later at Megara in 266 BCE, defenders literally doused pigs in highly flammable pitch, lit them on fire, and drove them right at the elephants. The resulting panic caused the elephants to just turn around and trample their own troops, a brutal biological solution to a complete tactical nightmare. We see this acoustic tactic again in the 6th century at Edessa too.
Moving on to Section 3. Mechanical and material misfires. The limits of the forge. As we hit the medieval and early modern eras, ambition starts completely blowing past the mechanical realities of the materials available. Take King Gustavus Adolphus of Sweden and his 1620s leather cannon. He desperately wanted ultra-mobile artillery. Step 1. Wrap a thin copper tube in heavy rope. Step 2. Seal it up in varnished leather so it's super light. On paper? Genius. You could pull it with just 1 horse. But step 3 is where reality hits. You fire black powder, and that insulating leather and rope traps all the extreme combustion heat. With nowhere for the heat to dissipate, the copper core warped, causing catastrophic materials failure. The gun would literally explode after just a few shots. The materials science just wasn't there yet. Now, if we look objectively at the 1718 puckle gun, it's a wild historical example of how early rapid-fire mechanics got entirely tangled up in the theological biases of the era. This early machine gun precursor literally patented 2 different types of ammunition depending on the target's religion: round bullets for Christian adversaries to deliver standard wounds, and square bullets for Turkish forces to deliver jagged wounds and, quote, convince them of Christian civilization. Wild, right? But ultimately, this subjective design didn't matter. The weapon failed because its hand-fitted, super delicate flintlock mechanisms just couldn't survive harsh battlefield environments. Let's look at the Girardinoni air rifle from 1779. The Austrian army eagerly adopted this pneumatic rifle, and the data shows exactly why. It fired 20 rounds a minute, compared to a standard black powder musket's 3. You could reload it while lying completely prone on the ground. And stealth-wise, 0 smoke and minimal noise, unlike the huge, loud, dense smoke of a flintlock. Tactically, the advantages were absolutely immense.
But here's the catch. 1,500. That is the grueling number of manual hand pump strokes a soldier had to do just to pressurize the weapon's fragile leather gasket's air reservoirs. The logistical burden was absolutely crushing. They needed specialized gunsmiths traveling with them just to maintain the seals. So it was a highly effective, brilliant weapon, but way too high maintenance for long-term military use.
Section 4. The absurdity of total war. Scale rockets, and pigeons. All right, stepping into the 20th century. Industrialized warfare and massive budgets meant engineers could build things on a staggering, sometimes comical scale. Take the 60-ton Russian Tsar Tank from 1914. It had these giant 30-foot front wheels designed to just roll over any trench. It looked terrifying on paper, but they completely botched the weight distribution. Basically, the center of gravity was too far back, so all 60 tons of its bulk shifted backwards onto this tiny rear steering roller. The second they drove it onto soft, marshy ground during its first test, that rear wheel anchored itself deep into the mud, completely immobilized by basic physics. And speaking of epic control failures, we have to talk about the Great Panjandrum. This was essentially a giant explosive wheel designed to blast a hole through the Atlantic Wall for D-Day, but it was doomed by a fatal lack of directional control. As the quote notes, strapping 70 unevenly burning cordite rockets to a massive wooden frame filled with explosives is just a recipe for absolute chaos. If even one rocket failed, the wheel spun totally out of control, actively hunting the very generals who came to watch it test. Now think about this. Before solid-state electronics and microchips, how exactly do you guide a missile? Enter Project Pigeon. In 1940, B.F. Skinner came up with a highly logical attempt to build a biological guidance system. He placed 3 pigeons inside a bomb's nose cone. They were operant conditioned to peck at a screen, literally steering the bomb via pneumatic valves connected to the fins. It even included a brilliant majority vote failsafe among the 3 birds. It successfully tracked targets in tests, but the military brass ultimately deemed it just a bit too eccentric to deploy. Section 5. Cold War Doomsday Devices. Apocalyptic Budgets. The fear of total nuclear annihilation pushed experimental engineering into totally apocalyptic territory, where designs were almost as dangerous to the user as they were to the enemy. 35,000 pounds. That is the tremendous thrust generated by Project Pluto's Supersonic Low-Altitude Missile, or SLM. This thing used an unshielded nuclear reactor to fly at Mach 3, just 500 feet above the ground. Its purpose was to purposefully rain highly radioactive fission fragments and devastating shockwaves all over everything in its path, before finally crashing and contaminating its ultimate target. It was the absolute definition of a doomsday device. And here we have an incredible thematic callback to utilizing animal biology to solve mechanical bottlenecks. In 1954, British engineers were working on Project Blue Peacock, which involved buried nuclear landmines. But they had a problem. The German winter was so cold it would freeze the firing timers. Their very real, officially proposed solution? Seal live, roosting chickens inside the bomb casing with a week's worth of food. The body heat from the birds would literally keep the mechanics warm. The political fallout of burying nuclear landmines in Allied West Germany is what ultimately killed the specific plan, but you have to admit, the ingenuity is undeniable. $20 million. That is the staggering amount the CIA spent on Project Acoustic Kitty in the 1960s. They surgically implanted microphones, a radio transmitter, and an antenna into a live cat, hoping its natural ability to roam unnoticed would make it the perfect spy against Soviet embassies. The result? During its very first field test in Washington, D.C., the cat's natural feline independence took over. It wandered right into the street and straight under the wheels of a passing taxi. A $20 million reminder that you just cannot perfectly program biology. Section 6. The Blueprints of Tomorrow. Validating the Weirdos. So let's bring this all together and look at the synthesis. Why does studying these historical oddities completely change our understanding of modern military tech? Well, every single weapon we've discussed today failed because it hit a wall at one of these 4 exact intersection points: control feedback loops, materials science, biological unpredictability, or logistical burden. This is where human imagination simply outpaced the reality of what could physically be built and controlled at the time.
And this is the main thing you should take away from this explainer. Yesterday's bizarre failures were absolutely not just jokes. They were the vital, conceptual blueprints for the standardized, highly effective tools of modern warfare. The Panjandrum paved the way for remote robotic mine plows. Project Pigeon's optical tracking is alive right now in digital targeting algorithms. And the Girardoni's rapid smokeless fire, that is standard in every gas-operated automatic rifle today.
It makes you wonder, doesn't it? When we look at today's discarded prototypes or seemingly ridiculous defense patents, which of them are just waiting for a breakthrough in material science? How many of today's dismissed, anomalous ideas will become the absolute, terrifying standard in 50 years once that engineering friction is finally overcome? Thank you for exploring